All right, so in this investigation, we're going to talk about the law of cosines. It's investigation 10. And the way we're going to begin is we're going to start by taking a look at this right triangle, and let's write the Pythagorean theorem for it. So the Pythagorean theorem says x squared plus h squared equals b squared. And what I kind of want to do is I want to solve that for h. So if I move the x squared to the other side, I get that. Well, I'm also going to take the cosine of angle A. Cosine's adjacent over hypotenuse, so it's x over b. And if I solve this for x, I get b times cosine A. In the triangle on the right side, let's do the Pythagorean theorem here. We're going to get that a squared equals h squared plus the quantity c minus x squared. And let's expand that c minus x term. So I'm going to multiply c minus x times itself. When I do my distributive property, I get a c squared, I get an x squared, and notice what's going to happen in the middle. I get a c times a negative x, so negative cx, and I get another negative cx. So I have a negative 2cx there. So now I'm here with a squared equals h squared plus c squared minus 2cx plus x squared. Okay, now I got things that I can make some substitutions on. Because earlier I knew what h squared was equal to. So now I have h, instead of h squared, I have b squared minus x squared. Okay, then I have my plus c squared minus 2c. Now hold on, because I also know what x is equal to. X is equal to b times the cosine of a plus x squared. And if I look at this equation, I see a positive x squared and a negative x squared. And what I have left with then is just a formula, if you will. And I'm going to write that CB in alphabetical order. What I have now is I have an equation that involves all three sides of the triangle and the cosine of one angle. That's what the law of cosine looks like. So to summarize a little bit, we call this the law of cosines. Now, we can rearrange the finding a side part a little bit. Let me see, was I good in kind of, I didn't stick all that together, okay. So if I want to find side B, I can write the equation like this. So I'll just put the A and the C together, but that means over here I have to do 2AC times the cosine of B. So notice the relationship between the side and the angle. Okay, whatever angle you have, the side is on the other side of the equal sign. And if you just rearrange the terms of the equation, you can solve for the cosine of the angle. That's all I did for the bottom one. So why don't we practice these a little bit? Let's use these two formulas. There's a beautiful thing. I'll show you this in class. In example number 11 on page 490, you're asked to find out a side length and an angle measure. Use your newfound law of cosines to see if you can get those measures. Alrighty, so in this first one, this is going to be side A, this is side B, this is side C. Notice something, that for the law of cosines, we want a side angle side relationship. If we have a side angle side relationship, we can then find the missing side. So the equation that we're going to use is that a squared equals b squared, which is the square of 14.7, plus c squared, which is the square of 17.9, minus 2 times 14.7 times 17.9 times the cosine of 62. Now, if you take a look at this equation, this gives you, this expression on the right side gives you the value of a squared. We want to find the value of a. So eventually, we're going to have to take the square root of all that stuff. Holy cow. So I'm going to go to my calculator, and maybe I'll do it in 2 separate steps. What are my numbers? 14.7, 17.9, and 62. Got it. So I'm going to do 14.7 squared plus 17.9 squared minus 2 times 14.7 times 17.9 times the cosine of 62. So that is the square of the side I'm looking for. So now what I'll do is I'll take the square root of that. I'm going to go square root of the previous answer. So to 3 significant figures, it's like 17, 17.1 or so. So side A or side BC, 17.0. Now, if we want to find the measure of angle A, let's see, maybe I'll move this problem down a little bit. Let's extend the page and grab this and move it down here. So I'm looking for the measure of angle A. This is the angle I'm looking for, which means in my law of cosines, this is the value that's on the opposite side of the equal sign. So the equation I'm going to be solving is 18 squared equals 21 squared plus 27 squared minus 2 times 21 times 27 times the cosine of angle A. So when we rearrange some terms, if I take the cosine A term and move it to the left, I'm going to get 2 times 21 times 27 cos A. And if I move the 18 squared to the right, I get 21 squared plus 27 squared minus 18 squared. I got to divide both sides by 2 times 21 times 27. Cancels that out. And then I got to do the inverse cosine. So A is going to equal the inverse cosine of this big calculation. There's what we got to do in our calculator. So let's see if we go to our calculator and we can pop all that in. Let's go inverse cosine. Check this out. I'm going to make a fraction template. Because on top I had 21 squared plus 27 squared minus 18 squared. These calculators are nice because you can make it look exactly like you want. It should look exactly the same on paper. Let me do a quick check. There's my expression calculator-wise. That's what I want it to look like. I'm feeling good. I'm pressing enter. My angle is about 41.8 degrees. Oh, here we go. 41.8 degrees. So using law of sines to find a side length, using law of cosines to find a side length or an angle measure, it's a great tool to use. So if you take a look on Google Classroom, I give you a nice question that involves a lot of the different trig stuff that we've done. It's from an old IB exam. Give it a shot and check your answers with the answer key.